Hello, Eric. Welcome to Elastic.
Hello.
Welcome to Elastic Community Conference, and we are really glad to have you here. And without any further ado, I don't want to waste your time. And the stage is yours. And
Terrific. Terrific.
yeah, yeah.
I'm really excited to be here. And really excited to see the progress of the Elastic community. It's been the key technologies that I've used in the last 15 years. So really excited to be here. And I'm really excited to be here to talk about one of the challenges that we have, which is in improving our search results. Because in many sort of traditional full text e-commerce search, these sorts of use cases where we're using Elasticsearch, a lot of people find that their search relevance, i.e., am I getting as a user the results that I wanted back, is broken, right? Many search applications, the most common feedback is your search sucks, right? And it's a really common problem. And this is why most people's search experiences is broken, right? This is actually a real conversation from back in like 2012 or 2013 between the creator of Quepid, my friend Doug Turnbull, and Rena Morse. And these two people were having a conversation about search. Rena was saying that when I search for myocardial infarction, these documents about heart attacks should be returned. And the reason is that she is a taxonomist, is a doctor, and knows that myocardial infarction and heart attack are the same thing. So, of course, the search engine should return it. So Doug takes that input, he goes off, and he works on that issue. And it takes a week, right? He's got to go out, he's got to mess around with some synonyms, some keywords. And then Rena comes back and says, okay, that's great. You fixed that one query, but you broke these other ones. And so Doug says, all right, let me see what I can do. I'll get back to you in another week, right? 2 weeks have gone by since Rena identified a problem. And the reason and what we're seeing here is kind of one of the best tools to fixing search, which is arming developers, i.e., in that conversation, Doug, right, with the knowledge of subject matter experts. Rena, right? Myocardial infarction and heart attack mean the same thing. One is the medically sophisticated term, and the other is what we use day to day. Unfortunately, though, it's not always so simple for the subject matter experts to speak to the search developers. And it leads to that broken workflow that we saw between Doug and Rena, right? Their collaboration was stinks, right? It's a 1 week turnaround. They're each talking at the other things are breaking, right? So when you make one step forward, you feel like you're making one step back. And this all leads to the iterations of improving search as being too slow. It's a difficult process. So that origin story of Rena and Doug trying to improve a medical search application was actually the origin of Quepid, which is a test-driven relevancy dashboard. It's a tool for letting the subject matter experts and the search developers work together. And so today, I'm going to give you just a quick, brief demonstration of Quepid. So here is what we call a case in Quepid, the Elastic Community Conference. And we're going to go and improve some searches for Star Wars, right? We like Star Wars, the movie. We're interested in going to see it. But, Star Wars is returning to us from Elasticsearch 2,898 possible search results. So we're going to talk about what are we actually looking for when we search for Star Wars. And we often call that the information need. What is our information need? and I'm going to go ahead and put it in my notes here. The information need for the query Star Wars is I am looking for one of the 9 major movies or one of the recent spin-offs. Rogue One, Solo, right? One of those. Maybe The Mandalorian if I had that in here, right? I'm looking for one of those 9 major movies or one of the recent spin-offs. So in Quepid, I've got my search query for Star Wars, and I'm looking here at search results. But one of the things that I need, and I'm sort of playing the role of Rena, the subject matter expert, is we need to rank or rate these documents. I searched for Star Wars, I found the movie Star Wars. That is just about the most perfect search result I can get. So I'm going to go ahead and give it a perfect result. Star Wars, the Clone Wars, right? Well, that's not one of the big 9 search result, big 9 movies. So I'm going to give it a, it's fair. Like it wasn't, some weird thing. A lot of people saw it, but it's not ideal. Here we go. We have The Force Awakens, right? One of the big 9 movies. And then we start getting some junk, right? These are bad search results. These are the kinds of results that make a user say, wow, your movie search is terrible. Star? What is that? I'm going to give it a poor. The Star, right? Again, a poor result. I've gone ahead and rated some of these other search results for us, just for time's sake. So what this lets me do is for my query, Star Wars, I'm actually using those ratings, and I've picked an algorithm, DCG, right there, DCG at 10, which is saying, let me look at the top 10 results, the at 10, and score them. And so right now, my search engine is giving me a 15.65. Okay, not bad. But let's see if we can't make search better, right? And so I'm going to kind of focus on this query and see if I can't get this number, this discounted cumulative gain number of 15 to go up. And the DCG algorithm is built around the idea that we get penalized for having bad results so high in the search results, but we get much less penalty if they're at the bottom. Okay. So in Quepid, I'm going to now play the role of the search engineer, right? Doug in this tool. And here is my query that I've got. This is just a basic query. I'm looking at title, overview, and cast. Well, one of the things that I noticed in my data was that I have a vote average and a vote count. Well, maybe what I could do is boost the search results on the vote average, right? Like let's put the movies that people say are good movies further up to the top. So in my query sandbox, this is my query, and you can see I sort of have magic syntax to put my actual query in here. I'm going to go ahead and rerun my searches against my Elasticsearch instance. And look, okay, got a little bit of improvement, right? I've improved the search results a little bit, but not much. And, when I look at my search results, it's like, oh, vote average 8, 5.9. The star, though, still shows up really high. And over in here, I have this like nice view that gives me some debugging, a sense of like which factors were important, right? And what it's saying is that vote average is, it's helping, but it's not a great solution. These highly rated, but not by very many people, movies are still showing up. So maybe instead, what I should be using to try and get a better search result instead of vote average is why don't I just go up with straight count? Let me trust the people. Let me assume that people, voting for a movie is a proxy for liking that movie. Let's go ahead and find out what happens. Isn't it nice that I can experiment so quickly here? Hey, look at that. Right there is a marked improvement in our quality of our search results. Star Wars, The Force Awakens, Rogue One, right? All the way down. Okay, we had a Star Trek sneak in fairly high, but look at the rest, right? We have good results. And this is the important thing, is that we need to not be anchored to, yeah, one not great movie showed up, but overall, we improved the quality of our search. And by how much did we improve the quality of search? Well, let me go ahead and compare my current search algorithm with one that I took at the very beginning when I first started this process. My current search is a 22.76. I started with a 15.65. And if I open this, I can see Star Wars makes sense. Clone Wars. But look, right here in rank 4, we've gotten rid of these bad movies, right there. And we continue to have good results. We've gotten rid of these bad movies. So, and then we get down to sort of garbage at the bottom. So this lets me experiment with my search results, tune my search, and have a measurable result. And I can do that across a whole swath of queries. So that's Quepid for improving your search results. So I just wanted to share really quickly. So Quepid was created by Doug Turnbull. Thank you, Doug. Back in like 2012. First public mention was back in 2013. So Quepid's been around for a long time. OpenSource Connections, we made it it used to be a product, but we made it open source with a free SaaS service that you can sign up and use back in 2019. And last year, we really started building community around Quepid. We had 9 releases. We have 15 contributors, of which 13 are new to Quepid. We have a Dockerized container that people are downloading, and we have somebody signs up for the hosted version of Quepid every single day. So very excited about that. There's some more information about Quepid. We're looking for more contributions. Join Relevance Slack, and there's a #Quepid channel. And look forward to sharing more about how Quepid can be used with human-rated judgments to improve your search. Thank you. And lastly, sometimes people ask me, why is it called Quepid? And it's to show your queries some love. Thank you very much.
That's a nice last slide, Eric, and I really enjoyed your presentation. And it's quite informational, and it also targets the right areas where one needs to look when it sets about search. Thank you for the presentation, and yeah, I don't see any questions. If you have any questions, please answer it in the chat. Thank you
Terrific.
so much.
I will hang around and love to chat about Quepid on Relevance Slack. So thank you very much.
Thank you.